my presentation is on adaptive metrics, or how I learned to stop worrying and love the button. The button that I'm talking about here, I don't know if anyone's seen the adaptive metrics feature, but there's basically a big button that says, like, save money, and we like that. All right. So we used adaptive metrics. It was easy, and it saved us a ton of money. Questions? So seriously, when the organizers saw that 3-slide slideshow, they told me I needed to fill it out a little bit more. So we'll add some context here. So what is the Trade Desk? What do we do here? We're an advertising technology company. We help agencies and brands target customers. Every time you load a web page, there's a huge series of auctions for your eyeballs. And we are the company, or one of the companies, that bid on these auctions on behalf of our customers. To oversimplify things a bunch, this makes us similar to a high-frequency trading platform with massive scale. So a lot of people talk about massive scale, but the Trade Desk more or less sees a vast majority of the traffic on the internet, and we interact with a large amount of it. So when I wrote this slide, that was around 18.7 million queries per second. But what does this mean practically for observability? This means that we stretch every single third-party solution to the absolute limit. And just to give you context there, we found bugs in AWS. Like that's the kind of scale that we got. So our team, the team that I'm on, the observability team, is called Service Excellence. We're not just responsible for monitoring observability. We do incident management and response as well. And we also manage a lot of our third-party contracts and integrations. Some of those include Grafana, we have Honeycomb, we have Sumo Logic, and a whole bunch of suite of other tools that we manage. This is another thing that gives you context to the amount of metrics that we're seeing in our system. I had to like count out the commas there to figure out how many series that we have. But that's like no joke, a whole bunch of data. That's 210 million. So what does our system look like? So as far as observability goes with metrics, we have metal data centers, we have Kubernetes centers, we have some cloud data centers, and each of those are running 2 Prometheus nodes. That ensures that we have very high uptime. And all those Prometheus nodes are working with an alert manager cluster that we have running. And that sends alerts to our internal alerting stack. We have something called Alert Gateway, which takes those alerts and enriches them because we want to do more than just what Alert Manager does. We also have something called Monitoring Adapter that takes our third-party alerting systems and transforms them into our own bespoke internal system. And we've just recently moved to Grafana IRM. We moved off OpsGenie. And that is what we use to both send alert notifications to our users and allow our users to view those alerts as well. We also have our system over here to view Prometheus metrics. That's in Grafana LTS. And you can see all of our Prometheus nodes are writing to Grafana LTS. We also provide a monitoring platform. I know Grafana would love us to have our alerts in their system, but we have so many like bespoke custom things that we've written a long time ago that our devs really love. So we have our own monitoring platform that pushes rules into Prometheus to evaluate. We also wrote this nifty thing called Metric Exporter, which takes database queries and converts them into time series. And that's a very useful tool that we built. So what do people use metrics for? A lot of people kind of wonder, like, hey, what does your team do? So we provide metrics. Every dev everywhere uses metrics, but it's especially useful when we're testing new features. It's critical for our alerting in our systems. But I would say, like, if you had to distill down to a single use case, one of our biggest use cases is comparing our releases. So we release on a weekly cadence for our main systems, and that means that we have a test and we have a control, and then I wish I could say we did something smarter than this, but we have a dev go through and kind of like look at the test and the control data and say like thumbs up or thumbs down as far as the release goes. So on SE, what do we spend most of our time doing? A huge amount of it is just maintaining that massive scale, which is upgrading servers, migrating to new infrastructure, and importantly, protecting our systems from oopses, which is when you have, I think we're somewhere near 500 devs in our company now. At least once a week, some dev will write a query that just blows up our cardinality. And we have to stay on top of that with all sorts of alerting to make sure that we're like, hey, did you really mean to double the cardinality in our system? We also address costs, which is different than those one-off oops. It's making sure that we are being as efficient as possible with our money, and building observability and response tools to make our developers more efficient. Something we just recently added was tracing. So we're always kind of building those new tools as well. And as always, pushing for best practices. Like we would love to sit, believe it or not, our team is almost entirely introverts. But sitting out there and attempting to train our devs on how to best use observability is a good use of our time. So what do we do here? Some example projects. One thing that we've recently done is moved Push Gateway to OTel. If you don't know what Push Gateway is, it's a way for transient jobs to send telemetry to Prometheus. And this was something that was really cool, I don't know, when we built it 5 years ago. But this is starting to cause a lot of problems. For example, there's delays between metrics being pushed and the information getting populated. You can't use counters. There's no easy way to clean up outdated metrics because they never expire. And we're shifting to OTel anyway. So what we decided to do was take our push gateway metrics and push them towards the open telemetry collector. And this was migrating a whole bunch of old crufty batch jobs. And I'm sure everyone out here knows that like the most tech debt is always in those batch jobs for some reason. So there's a lot of touching some of the oldest things in our system. And as always, communication is key. Just talking to teams and helping them understand why we're doing this. And this is the solution that we came up with. So over here, we have our different instrumenting applications. We have to do both K8s and physical since we're in a transition period. And excuse me. The way this works is we push it to the OTel agent collector. We hydrate the metrics. We push that to a gateway collector, and then Prometheus scrapes that. We have this thing right here called a skip agent that we built to a global collector, because the way that push gateway works is you had no sense of like the instance things were running off. So a lot of our back-end dashboarding was based on the assumption that we didn't care what service our job was running on. So we had to create a way to make it look like our things are global. Uh-oh, my laser pointer's gone. No laser pointer. Templated alerting is another project that we did. So our company, we're moving to Kubernetes. It's been a very good move. The company has saved a lot of money. It's made our devs more efficient. But one thing that we noticed when we were doing that migration is that different teams were all building their own system-level alerts and queries into our system, which was making it very difficult because there was no canonical way to find those system-level metrics. So we needed to figure out a way to be like, hey, how can we make it as easy as possible for teams to alert around their system-level metrics in Kubernetes? So what we did is we added a custom resource. Oh, it does work now. A custom resource so that they could get high-quality system-level alerts. And when you let devs build their own stuff, when they have a ton of product pressure, you tend to end up with like terrible best practices. So this is one way that we could be like, hey, it's even easier to just add this custom resource. You'll get high-quality alerts, and you don't have to write your own. You'll save time. Win-win. And of course, we had to provide a mechanism to override those defaults. So this is the way the system looks. Over here to the right, you can see this is how an engineer would override some of those alerts. They can set their own thresholds for the alerting. They can set their own severity as well. And the way that it works is you have those custom things over here, like the kube state metrics, which is a way that things, metrics in Kubernetes get populated to Prometheus. And then you have the custom resource that we wrote down here, which has a K8 API where you can have our rules over here that we talked about earlier. They get populated into those kube state metrics. So best practices, how does our team operate? We run an operational health meeting. If anyone has an observability team here, I have found this to be extremely useful. It's a great way for a team that has a lot of moving parts to keep eyes on all those moving parts. It's also a forcing function to ensure that we're keeping an eye on all the things that we need to keep an eye on. If it's something that happens once a month, everyone's like, all right, I need to look at versioning. I need to look at resource management. I need to look at the amount of alert noise that we're generating. So what does that look like? We can identify some anomalous usage. That's the kind of the spikes that we were talking about before. We can take a look at our alerts over time. This is our own custom dashboards that we've written in Grafana. So I can see hey, we're making less noise here, but why the heck is this alert going off again? We also have our own SLOs. This is another thing that we built before Grafana had their SLO product. And we like our internal thing a ton. But you can see in the operational health meeting, we can review hey, what are our systems that aren't doing so well? And how much work do we need to put in to make them better? So now kind of on to the meat of the talk. We had a problem. And I realize now, my boss is in the audience, this presentation is about bad decisions that I made, but it's after review, so I think I'm good. So up and to the right is good, right? Nope, not when it comes to costs. This is what our costs look like, which is bad. Those are big numbers. It's going up and to the right. So how did we go about fixing that? Well, Grafana tried to help. They suggested that we use adaptive metrics, but as you'll see in a few slides, we didn't do that right away. There's a myriad of reasons. We run both self-hosted and Grafana Cloud. We were an early adopter of Grafana Cloud, and for a lot of reasons, we wanted to use our own custom backend solution that we were using along with Grafana Cloud, which meant that using adaptive metrics wasn't as simple as just hitting the button. And here, Grafana also offered professional services to help migrate our system to adaptive metrics, but we refused. And I'll kind of get into the reasons that we did that later. But a main reason, and I'm sure all of you suffer from this, engineering time at the trade desk is super tight. And we need to be extremely intentional around how we spend engineering time. Grafana told us that we could save an average of up to 40% with adaptive metrics, but I came in hot with the smug and was like, other companies probably could save that much, but we're on top of it. We run meetings where we look into our metrics. I have devs go out and investigate how much we're using various metrics. Maybe they could get us 5%. That'd be great. And we really couldn't prioritize it because we had no clear understanding of the return on investment, which is hard to do because you don't know how much adaptive metrics is going to save you until you can hit the button with our system. But a lot of people out there can probably, if you just use Grafana Cloud, you can see how much you can save right now. I joke that I went through a series of phases of acceptance. If you know anything about psychology, there's a bunch of different phases. So my first was denial. I kind of talked about that already, but we have a good process to detect high cardinality metrics. Yeah, it couldn't save us that much. And then there's anger, and I'm sure you've never gotten angry at your devs. It's those damn engineers. If only we could get them to consider their telemetry costs when they add metrics to our systems. Then there came into the depression. I don't think we could change the culture here. Devs have too much on their plate. There's nothing that we can do. And then there's bargaining, which is maybe if I loan out some of my team's time, we can drive down costs. And then acceptance, maybe I should just hit the button. So eventually we found the time to do that. Turns out problems you ignore don't go away. And cost kept exploding. I transitioned from thinking that, hey, this increase in cardinality is a one-off. You know, Team X is doing this, Team Y is doing this. You know, eventually we'll just level out. And then I came to the acceptance that, hey, I think this is going to continue going up and to the right, so we need to address it. And our organization is also migrating to Kubernetes, which I mentioned, which saves us a ton of money, but it also explodes the cardinality because of those system-level metrics. So what did we do? We invested a little time to see what adaptive metrics could give us. It required us to migrate all of our internal dashboards to the cloud version of Grafana. We had to migrate all of our globally configured alerts into Grafana Cloud. Like I said, we have that custom alerting monitoring platform. But all in all, this was a relatively short investment. I think it took about 2 weeks. And I was like, all right, let's see what it gets us. And holy shit. I didn't expect that. Big number. So communication strategy. After we saw the number, we were really excited. But you know, it's not something that I can go do. I mean, I could go hit the button, but you know, I want devs to understand what's going on with their metrics. We explained why. You know, it's pretty easy to make an argument when you see a number like that. But telling them what exactly is happening, letting them know that we're not permanently taking their metrics. They have the power to undo any changes that we're making. And something that I've learned a while ago is visibility is one of the most important things here. Making sure that you send an email, making sure that you post on Slack, making sure you do this 4 or 5 times. Because you know, even if you do that, 10% of devs are going to be like, what? I didn't know. So making sure that you're visible. And I tell everyone, including my boss, very excited. But you know, we ran into a problem. I thought I was being smart. I was like, I want to make this as easy as possible for teams. I had a list of suggested adaptive metrics to drop. We have a janky back-end way to join those metrics to teams so we can tell like which teams are spending most of our money. So I go to dev and I'm like, hey buddy, do you mind joining the metrics to the teams so that I can just send a subset to teams? Can anyone see a problem with that? I just touched all of our metrics. So we went from saving a huge amount to it being like, nope, every single metric in your system is used to perfect, which is not great. I took careful aim at my foot. The cool thing about this is we absolutely know the feature works. We touched all the metrics. It all went away. But Grafana came to the rescue again with a top secret feature. You can see that they're like, oh yeah, we only use this internally, but we'll turn it on for you, which was super helpful. And we went back to cutting a large amount of metrics again. So future work. I want to talk a little bit about what we're thinking when it comes to telemetry. There seems to be a tension in the observability world. Developers still care a ton about these instance level metrics, even though we're migrating to Kubernetes. You know, people talk about cattle, not sheep all the time, but people still want to go in and see what their individual boxes are doing. But that costs a ton of money. If you know anything about cardinality, that explodes cardinality. But they only care about it for a very short time. So what options can we provide? We thought about 3 of them in our system because we still need to save money here. The first one is federation. Our Prometheus servers provide a variable 3-day lookback. This is constrained by disk. So it can go up, it can go down, depending on the load in our system. And the thought was we could provide a light front end that provides devs a centralized area to query any Prometheus server. The pros of this solution is it'd be super easy to stand up. The cons of this solution is it's terrible user experience, and like devs are kind of okay with that. But the more important thing there is we want more than 3 days, or the devs want more than a 3-day look-back window. All these options are bad, by the way. Option 2 is streaming aggregation. So one neat thing that we thought about is putting an agent between our nodes producing metrics and Prometheus that aggregate on a specific label before sending it to Prometheus. And the cool thing about this is that this saves us load on our Prometheus servers, which, like I said before, is something that we're always looking to do, is relieve pressure off of our systems. But the cons is we lose those instance level metrics altogether, forcing devs to opt out if they want those gains. So yeah, we might save on, let's say, 50% of the metrics in our system. But if devs are opting out of a large amount of them, we're not going to see what we really want to see. And our third option, and this is the one we're probably going to go with, is medium-term storage. And this is where we're adding another mid-term storage. We're thinking Thanos right now, that Prometheus can do remote writes to, in addition to our long-term storage. And then we can use recording rules to compress those metrics that we're putting into long-term storage so the developer can go to the smaller mid-term storage if they want to get instance-level metrics, and they can shift to the LTS if they want longer-term storage. And the cool thing about this is that customers get exactly what they want. But on the flip side, we found Thanos to be flaky in the past. We're concerned about uptime. And this is a solution we don't think we can continue to scale as we move into the future. So this solution buys us time. It doesn't really solve the problem permanently. So then we start thinking about ultra high cardinality. And now we're kind of in la-la land. These are ideas that devs spit out without really thinking about them, myself included. So how do we handle the future when devs want these super high cardinality information, but that's something that's just not financially feasible. One option we've thought about is downsampling. So how can we provide extremely high cardinality for short periods of time and then downsample and aggregate as time goes on? So devs can get that short look-back window that they're really looking for, but when it goes to that longer-term storage, it's more compressed. And maybe that would be a series of like really short-term metric storage, medium-term, medium, long-term, and then long-term. Another one is stochastic methods. Could we find some sort of way to determine statistic significance so we could automatically drop time series and the developers could still conduct the experiments that they wanted to see without having all the data in our system? Another thing we've thought about is tunable granularity. Can we provide tools that allow devs to increase cardinality and sampling rate for short periods of time? This is another thing where, let's say there's an IM, they could go out there, they could say, all right, let's crank up the cardinality on this feature to get more information. And the last thing that we've thought about is verbose servers. Can we have 99% of our fleet running on reduced cardinality while a much smaller set produce a much more verbose set of logs, metrics, traces, so that if there is a problem, hopefully it's caught by that system. Other stuff, I'm running out of time, so I'm going to race through this. We're also the largest user of Grafana IRM, which means we're beta testers. Grafana has been super responsive in our asks and working with us here, but there's still plenty of features that we want. We also migrated off of Grafana IRM, or not off of Grafana, from OpsGenie to Grafana IRM. And this is way too long to squeeze into this presentation, but the story is just as exciting, so you can come and talk to me afterwards. I also want to say thank you to the team. I really do mean this when I think we're the best monitoring observability team out there. So if you're interested in working with us, let us know.